Hi kids, I love this unit. It's fun and hopefully it'll make a lot of sense to you. Anyhow, we're going to start out by talking about congruent figures. And the idea of congruent figures is that they have the same size and shape, just like you would imagine congruent angles or congruent lengths of segments. When two figures are congruent, you can flip, slide, or turn one so that it fits exactly on the other as shown. And in this lesson, you're going to learn how to determine if geometric figures are congruent. But you can intuitively imagine that, yeah, those are the same shapes, right? You might have to do some manipulating in terms of turning, but you're not scaling them up and down or anything. They're set sizes and they fit on top of each other if you do the right thing. Yep, keep that in mind. Now, congruent polygons have congruent corresponding parts, meaning their matching sides and angles have the same length of measure or the same degree of measure, okay? When you name congruent polygons, you must list the corresponding vertices in the same order. So you can see how B goes with F, right? And A goes with E. You'd have to flip this kind of like across that line of reflection, okay? So what lines up with what? A lines up with E, B lines up with F. So what you get here is the first letter A corresponds with the first letter that matches it, E. B corresponds with F, C corresponds with G, and D corresponds with H, right? And so therefore, then we can say, let's take a look at the first two letters, AB. That's this side right here, okay? And that corresponds with EF. That's right from here to here. Segment AB or side AB is congruent to segment or side EF, just like that, okay? And we can then run through the name if we've got all the vertices lined up correctly, and we can do it like that. BC, side BC corresponds with side FG, right there, okay? And we can do this all the way around. And the fun fact about this is, okay, so here we got CD, side CD corresponds to side GH, that's this right here. And what about for the last one? Well, for the last one, we've got to kind of jump from the end to the front. We can say D as the last letter to A, D to A corresponds with H to E right there. And that's what you see right there, okay? So as long as you pick the same letters in the same position, like the last letter then the first letter, if you've written the name right, then you're going to get it correct. And we can do the same thing with the angles. Since vertex A corresponds with vertex E, then angle A is congruent to angle E. Okay, since C corresponds with G, angle C is congruent to angle G, etc., all the way around. Got it? Okay. That is contingent upon you writing the name in the correct position. You write each vertex that matches in the correct position, and then you can just say, what are the first two letters? That corresponds with the first two letters for that side, etc. And the same thing with the vertices for the angles. So if we were to do that, like I just said, then if Hij is congruent to LMNO, which you see over here, then what are the congruent corresponding parts? Well, we can first say straight away that angle H is congruent to angle L, right? And you can see them, H and L right there, okay? And you can imagine if we kind of flip this and oriented it, you'd get it on top of each other. But you don't even need to visualize it. You can have it written in the names. So we can say, okay, then angle I is congruent to angle M, angle J is congruent to angle N, and angle K is congruent to angle O. And we will see that when I uncover the answers here. Oops, right here. And the same thing with the sides. Remember what I said about the sides, okay? Side HI corresponds to side LM, and that's the same thing. And you have to write them in the right order. You should say HI, side HI is congruent, or segment HI is congruent to segment LM, not ML. It's still the same side, named in a different way, but you want each vertex to match with its matching vertex. So since H matches with L, if H is listed first in the name, L should be listed first in the name. It's just an important detail, okay? And you can go all the way around, IJ and MN. So side IJ is congruent to side MN, etc. Okay, oops. Now, how do you know which sides and angles correspond? As it says, it tells you in the name. It is the congruence statement, they call it. This is the congruence statement. Got it? Okay, so I put this large so that I could underline it, but I've already done it up there, right? So if I said side KH, right here, KH corresponds with what? Well, I went to the last letter and then the first. So O, side OL. There it is, in that same order. Got it? Okay, well, if you do got it, why don't you give it a shot here? This got a problem. Great. So here are the wings of an SR-71 Blackbird aircraft. This is the diagram of it. Okay, the wings suggest congruent triangles right here. Suggest it. Now, the reason that it suggests it is you're not really supposed to be able to go on the illustration, but obviously for something as high tech as this, they're not going to have it be asymmetrical. It's going to be perfectly balanced so that when it's in flight, it's not, unbalanced. So this is 30, this is 30, this is 75. What do we think D is? Oh, they're asking about D, not about F, which would be what corresponds with it, right? Okay, so if we know that this is 30 and this is 75, and that totals up to 105, what do you think is left for this right here, this angle right here? Okay, oops. And this is an important bit. How do you know? You know two angle measures. How can that help? Well, remember, if A corresponds to D and we know what B and C are, if we can find A, then we know that since that's congruent, then we can know D. So we first have to calculate that, right? So let's do that. And here they say measure of angle A plus 30 plus 75 has to equal the total of 180 in a triangle. So if you add those and get 105 and subtract it, you find that the measure of angle A is 75. And since these are congruent, then measure of angle D is also 75. So the answer is B. Okay. Suppose that, and they just write these down, so you're going to have to sketch this. You're going to have to write these triangles down. Suppose that WYS is congruent to triangle MKV. If you know the measure of angle W is 62 and the measure of angle Y is 35, what is the measure of angle V? And remember, you have this congruence statement right here, so you know which vertices go with which vertices on the other triangle. So sketch them out and see if you can sort this out. Okay, so they're saying, are the triangles congruent? Well, what do we need to know? We need to know that every part is congruent to another part on the other triangle. And so what do we know? Well, what we know, based on what was given, is that side AB is congruent to side ED right here because of the angle marks, okay? We also know that BC is congruent to DC because they're both marked as 4. Yep, and we know that AC is congruent to EC, AC and EC because they're both marked as 6. Now, we also know that angle A is congruent to angle E right here. That was given. And we know that angle B is congruent to angle D. That was also given. Okay, so we have 5 of the 6 things. We have 1, 2, 3 sides are congruent, and 1, 2 angles are congruent. We just need to know about this last angle. And what do we know? Well, we can't name it with just C because there's multiple angles coming off it. So we can say angle BCA is congruent to angle DCE because they're vertical angles and vertical angles are congruent. Now we know that triangle ABC is congruent to triangle EDC by the definition of congruent triangles, meaning we know all 6 parts of the triangle, all 3 angles and all 3 side lengths, are congruent. So therefore, the triangles are congruent. Okay. What about this one? Is triangle ABD congruent to triangle CBD? Justify your answer. Go slowly, think about all the things that you know, and be sure about what you know. All right. So what this says is that the triangle angle sum theorem says that the sum of all of the measures in a triangle must equal 180. So this follows from it. And what does this theorem say? The third angles theorem says that if 2 angles in one triangle are congruent to 2 angles in another, then we know that the third angle is congruent. C must be congruent to F because if A and B are the same as D and E, they're going to add up to the same amount, leaving the same amount left out of the 180, right? So this plus this taken away from 180 is going to be the same amount as this plus this taken away from 180. So therefore, angle C is congruent to angle F. The third angles theorem. If you know 2 angles in a triangle are congruent to 2 angles in another, you know the third angle is congruent as well. Neat. Okay. And here is a proof of it, in case you want to see it. Given that angle A is congruent to angle D, that's the single angle marks, and angle B is congruent to angle E, those are given, prove that the angles C and F are congruent. And here's how you do it. First of all, that information is given. Then we also know that by the definition of congruent angles, we can say that their measures are equal. Measure of angle A is equal to the measure of angle D. Measure of angle B is equal to the measure of angle E. Okay, so now we can say if we know that the measure of angle A plus B plus C equals 180, that is the triangle angle sum theorem. And we also know that the measure of angle D plus the measure of angle E plus measure of angle F is 180, also the triangle angle sum theorem. Then we know that through, they say the substitution property, we could also say, do you know what else we could say? Yes, the transitive property of equality, that the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. And watch what we can do next. We can say, okay, we can substitute for A and B right here, the measure of angle A and the measure of angle B, because we know that these are equivalent amounts. We can substitute those in through substitution and then subtract those amounts away that are the same on both sides. And once we do that, we get that the measure of angle C is equal to the measure of angle F, and therefore angle C is congruent to angle F by the definition of congruent angles. Neat, right? Okay. All that to say that it's true that if you know 2 angles are the same in 2 different triangles, then you know the third angle is the same as well. Okay, so here we've got a proof that given that segment LM is congruent to segment LO, that is congruent to that, and we see those single segment marks, so we know that's true, and that segment MN is congruent to segment MON, that's also given with the double angle marks, and we know that the angle M right here is congruent to angle O, and we also know that angle MLN right there is congruent to angle OLN right there because of the double angle marks. Prove the triangles are congruent. Interesting. Well, what do we need to know? And this is a big part of it. What do we need to know? You know 4 pairs of congruent parts. We need to know the other pairs. We need to know the third pair of sides and the third pair of angles. Okay. So that information was given to us that the sides are congruent. So we also know that through the reflexive property of congruence, this side is congruent to itself through the reflexive property of congruence. Remember that? Okay. And we also know that the angles that they gave us that were congruent are congruent because it was given. And by the third angles theorem, we know that that last angle, angle MNL, right here, is congruent to angle ONL right here. And notice that not only did they name the angle correctly, but they named the corresponding vertices in their correct position with the other matching ones as well. Okay, so then what do we know? By the definition of congruent triangles, since we have all of the information now, those missing pieces of information that we didn't have before, we know that triangle LMN is congruent to triangle LON. Nice. Cool. What about this? Given this information, prove that these triangles are congruent. Okay, give it a go. Okay, in the coming lessons, we will learn some ways to shortcut what we know and have less information before we can prove the triangle is congruent. But right now, you need all 6 parts of the triangle, all 3 sides, all 3 angles congruent to know. So you can try and fill in these given statements, these lesson check problems, and see how you do.